Hey everybody, we are going to be talking about random variables today. And before we actually get into what a random variable is, we need to review what a function is because a random variable is really a function. Okay, so remember functions go from one set to another, and they follow some rule. Right, to take an input and give you an output. And the main thing here, the main thing for a function is for each input, there is exactly one output. Okay. So random variables are going to be functions that have to do with probabilities and sample spaces. Okay, so random variable, right, basically it's going to associate a number to outcomes of a probability experiment. And how we are going to do that, so basically it is a function from a sample space into the real numbers. Okay, so not super complicated. Let's look at an example. Okay, so function from sample space into real numbers. We're flipping a coin, and we're going to assume that this is a fair coin. So do me a favor and remind me, when we're flipping a fair coin, what's the sample space? And I'm going to pretend that everyone, while they're watching this video, says the sample space is heads and tails. Okay, so essentially what we are going to have here is our function, our random variable is going to take, these are going to be the inputs, and then our outputs are going to be whatever numbers we want in R. Okay, and I am going to call our random variable x. So we're going to say let big X be the random variable that does the following. Okay, so basically, right, the only inputs we have to worry about are heads or tails, so I need to define our function on that. So we need to define what x of heads is and what x of tails is. And I'm just making up this example. I can make those numbers be whatever I want. So I can make x of heads be 8. I can make x of tails be 3. Excuse me. It's just like we're in class, you guys. I can't stop coughing. I don't have corona. I haven't had a fever. Okay. Anyway, so I could have had those numbers be whatever I wanted. They could have been 0. They could have been 1. Could have been whatever. But this is what we're doing. The main thing to remember here, or one main thing to remember, is that these numbers are not, we're not bringing probabilities into it yet. They're not probabilities. They're just numbers. Okay. Let's look at another example. I don't really know how I did that, but that's okay. Let's look at another example. Okay, let's roll one fair die. So our sample space here is the numbers 1 through 6. Okay, and let's define a random variable. So let's define a random variable x such that last time we just picked random numbers. This time we'll have x take whatever we get, whatever our roll is, and multiply it by 3, such that x of an outcome, let's see, what notation do I want to use here, such that x triples the number we roll. Okay, so for instance, if I roll a 1, right, x of 1, x triples the number that we roll, so I would get 3. Okay, what would I get if I look at 4? It triples the number that we roll, so we would get 3 times 4, which is 12. Okay, so I would suggest that you take a minute and go ahead and write out the rest, right? Write out x of 2, x of 3, and so on and so forth. Okay, so that is the basic idea behind a random variable. Okay, it's just a function, takes an outcome from your sample space and assigns a number to it. We are going to talk about a little bit more because we are going to get into probabilities here. Okay, and let's go ahead and do that on this next example here. We'll leave our random variable up here. Okay. All right, so probabilities and random variables. Okay, so we could, basically it gives us a nice notation for talking about probabilities. So we could ask about, say, the probability that we roll a 4. And the way that we've done that is we say, okay, we're going to call that event E, and then we find the probability of E, right? So every event you have to introduce notation and then talk about probability of that notation. However, right, with random variables, okay, probability that we roll a 4, well, that's when x is equal to 12. So look at this sort of nice, right? X is equal to 12, right? If we have our random variable notation built up, that's just nice mathematical notation. So instead of talking about probability of E, we can talk about the probability that x is equal to 12. And we know that that is 1/6, right? Because there's 1 out of 6 options is rolling a 4. Okay, so it essentially gives us a way, it gives us a way around defining events. Okay, and let's see, there's a little bit more that we're going to talk about here. Let's do an example. Okay. So let's do an example. So let's have we roll 2 fair dice, and we're going to let y be the random variable that gives the sum of the outcomes on the dice. Okay, so we've actually really been talking about this example a lot, right? We've done many probability examples where we roll and then we add the 2 dice together, and this is just giving us sort of a nice, a nice way to do it. So our sample space is things like this: 1, 1, 1, 2, 2, 1, lots of different things. And remember, size of the sample space, we're rolling 2 dice, 6 possibilities for each. So we get 36. Okay, so let's think about first part of this example. Let's find y of the roll 6, 5. And remember, y is the random variable that gives the sum of the outcomes on your dice. So that would be 6 plus 5 is equal to 11. Okay? Similarly, if we had y of 3, 3, right? All y does, it follows the rule of adding them together and gives you that outcome. Okay, now let's bring some probabilities into this. So let's find the probability that y is equal to 10. Okay, so I'm just going to write out outcomes where y equals 10. Well, I could roll 2 5s. I could roll a 4 and a 6. I could roll a 6 and a 4, and that's it. So that's 3 out of 36 outcomes. So over here, I get that the probability that y is equal to 10, well, that happens in 3 out of 36 outcomes. If we want to simplify, let's see, that would be 1 over 12. Okay, we're going to do one more example here. You might be interested in why this random variable notation is so useful. And it gives us the language to do a little more easily. Okay, so for instance, we could talk about the probability that y is less than or equal to 3. Okay, so now we want outcomes where y, that sum, is less than or equal to 3. So less than 3, we could have 2, and we could have where they're equal to 3. Okay, so basically this notation, right, that is a lot simpler than writing out the event where the sum of the two dice is smaller than or equal to 3. Okay, so again, that's 3 out of 36. So we would get that our probability is 3 out of 36, or 1/12. And that is going to be it for this video. We'll pick up with more probability functions on the next one.